Hello, Giovanni.
Hi. Hello, everybody. I know I'm not the only one in this room.
Yeah.
We're gonna have fun, okay? So I want everybody to kind of like drink and have fun, okay? This is not a super technical thing where you're gonna have to think really hard and stuff like that. So relax, have fun, and enjoy. My name is Giovanni, and I am doing my first drink and learn today on artificial intelligence. Meet your new friends. I'm going to show you how they are helping you do your things right now and how you are helping them do their thing right now. All right? So first I'm going to start off with a little bit of history, a little bit of how interactions have developed over time. Back in the day, it was pretty manual, very machine-oriented interactions, where if you made a phone call, there had to be a physical person connecting the call. If you had a calculator, you had to type on the calculator. So that's a machine-oriented interaction. And then time progressed. People got a little smarter, a little lazier, if you will. And then we started having what we know now as control-oriented interactions, which is very simply Outlook or Gmail. When you push a button, executes a function. You do something, it does something else. That's kind of where we are now. And right now we're on the precipice of another third generation, and we are calling it intent-oriented interactions, similar to chatbots and things like that, where the interaction is based on what you intend to do. If anyone's using a chatbot now, chatbots are really simply this. It takes your intent, say booking a hotel. You wanted to book a hotel. I know the context of what you're about to talk to me is going to be referring to booking a hotel. So you say, so that's the intent, to book a hotel. And then what to do about that is essentially it's based on your utterance. The spoken or typed phrases that invoke that intent. So you say, hey, Mr. Chatbot, I want to book a hotel. Chatbot says, okay, cool. I know you're going to book a hotel. You're traveling. What city? And your response is considered a slot. For programmers, it's just a variable, things like that. So that's your slot. And then as the conversation keeps going, you get to the end where it actually fulfills your request. I'm not getting too deep and too technical because I want to keep it fun and have a lot to go. So, any questions so far?
I do.
Yes.
So the terms that you use so far are those terms that developers are using?
Yes.
Like you would say slots?
Yes.
And utterances?
Yes. If you're programming a chatbot, you are using those terms.
Okay. Okay, we'll start using them.
Okay. So artificial intelligence. What is artificial intelligence? Is it robots? Is it machine learning? Is it deep learning? Like, what is it exactly? It's so you don't know what it is and what's what. So I'm going to break it down a little bit for you now. Think of it like this. AI, this stands for too long, didn't read. People should see that, so I'm going to break it down for you really easy. Think of AI as the hardware or the edge case. In this example, it would be the wind turbine, or the self-driving car, or the chess game that plays you in chess. That would be the AI layer, the artificial intelligence. Then the deep one below that would be the machine learning layer, which is actually a function to that data. We actually do something with that data, get analytics or something like that. If you're lost now, don't worry, I will get more in depth. And then the deep learning is essentially a neural network structure on top of that data, on top of that hardware. Okay? And kind of loosely how that infrastructure works is you train in the cloud and you predict at the edge. What I mean by cloud is in the internet. What I mean by the edge is right here, where you are. For example, if you have a drone, smartphone, a Mac, a computer, those are the edge machines. And then all the other in the cloud is where the machine learning and the deep learning comes in. So you throw all that stuff into the cloud and it trains that model on top of that data. So all of this is considered in the emerging technologies category. And this is a recent graph that I brought up. I'll give you guys a second to look at it. Basically, it's a hype cycle for emerging technologies by Gartner. Going up, this is the expectation. The color of the dots is how long they expect that to be out in the public. So as you can see, some things are already kind of here sooner than what they think, like edge computing, smart robots, things like the Roombas, the IoT platform, which is Internet of Things right now, like your security camera, things like that. Virtual assistants, they say is going to take 5 to 10 years, but it's here now. Everybody has Google, Alexa. In the connected home, deep learning and machine learning comes in right there. Autonomous vehicles, well, everybody knows what a Tesla is, but yet not for another 10 years? I don't know. So this is just kind of a little chart to kind of give you an idea of where we are in the technology space, if you will, as far as timelines and expectations. So, dictionary definition of machine learning is what gives computers the ability to learn without explicitly being programmed. Any questions? Because I actually had someone who had a question after I said that. So, a good example of that is all over the place. Self-driving cars. When you watch Netflix, they give you recommendations. Text recognition, when you scan something in. Spam filtering in your Gmail. These are all examples of machine learning. Netflix takes what you watch, learns what you watch, gives you recommendations. Amazon does it the same thing when they recommend other products, things like that. So that would be an example of machine learning. So if that's machine learning, what is deep learning? Well, deep learning is a form of machine learning that uses a model to compute similar to how the brain works. And I'm going to show you that, a very cool slide coming up pretty soon. So a good way to explain that is examples. Everyone loves examples. So what's an example of deep learning? Here, computer vision, image recognition, object recognition, natural language processing. When I type in something to a chatbot and it responds back in what would be considered a natural type language. Recommendation systems, anomaly detection, things like that. Predictions of the stock market, healthcare. So if you put all of this data through the machines, they can use deep learning to get these things. Here's one example. Here's another example. In real time, image recognition. Knowing that there's a face in the picture. Looking at a CAT scan, knowing that that's a brain or a back or whatever you're looking at. Right? So if that's one example. Here's another one of if you want. So how the machines actually do this. So what happens behind the screen? What you don't see, how it actually recognizes it. This is what goes on behind the screen that you do not see. This is how your picture or your text gets put into a neural network or the machine so that they can learn. Very simply, if you upload a picture, say this is your picture, it takes the low-level features like the dramatic differences in colors between black and white and directions between left and right and up and down. So it takes those are considered low-level features, the very small to the pixel dramatic changes. And then the next one is the mid-level features, there's one step above that, where it's like, okay, well, what is that around that? What does that comprise? And then the high-level features is essentially the face itself. So as you can see, you have the analog to the digital. So you see that, the machines see this. I'm not going to explain this for all the mathematicians, but this is actually the math that the machine goes through to get there. So if any of you mathematicians want to send this to you, if you want to try it out and whatnot. Any questions so far? Nope, we're good? All right, I have another example for you. So that's image recognition. So of course now, the only other thing is language. I need an example to show how natural language processing works. So when you type something in to an assistant or something, this is how it actually parses out what you're reading or what you're saying. And then using those different things, I can do what I need. Book your hotel, order your car, lower your temperature in your house, things like that. So there's the machine neuron, and then there's the brain neuron. So the machines are, what we're trying to do is essentially replicate a brain neuron digitally in a computer. Of course, that's all math. This is what that looks like. This is your brain. This is the brain of a machine. Again, I'm not a mathematician. If anybody wants to solve these, go right ahead. So this is a computer-generated neural brain cell, if you will, that mimics an actual brain cell. This is the code that does that. Again, I'm not going to explain it because this is not a technical thing. So what's this used for? Okay, I get it. We can train machines to learn stuff, and we can tell them to learn stuff from us. But how is this actually used? I have another example for you that I bet you don't even know. It's used in movies. It's used a lot. Neural transfer is used a lot, more than you know. The Twilight movie, Kristen Stewart is the girl in Twilight. She actually made a movie called Come Swim. And there was a treatment on Come Swim where she actually used neural cell transfers, where this was the input, this was the source given, this was the style that they wanted to put on this picture. After the machines got through with it, this was the output that was in the scene. It was also done on the cover of the Twilight film. So instead of actually shooting two things, movies, and then try to do some CGI put together, you take two photos, two videos, and you feed them through the computer so you get the style that you want.
I don't quite understand that example.
Wait for my next slide, and I'll show you how it works.
That was practice, by the way.
Glad you asked. This is similar how it works. So say I gave the machine this picture of the Golden Gate Bridge. I like that picture, but I want it to be styled in a very animated type style. So what you can do is you can feed both of those to the machines. Do you have any idea what that output would look like? Probably not. Like this. This is a machine drawing art for you. You give it the inputs, and this is your output.
Why did the machine make it bigger?
I made it bigger so that you could see it.
It's very proud of it.
It was its
pride too.
It was its favorite photo.
You better put that on the refrigerator.
Or the refrigerator. So, of course, with all the machines, all these learning, every brain needs to be taught. How do you feed the machines? How do you tell them the education? Everybody goes to school, so what's school for a machine? How do you put all that information in there? Well, you do it every day when you fill out a CAPTCHA. Every time you fill out a CAPTCHA, there's always two parts to it. One part that's known, and one part that's unknown. So there will be a distorted word. For example, in this one, the Google Maps car was probably driving by an address, saw that, recognized that that should be an address, but can't quite make out that that's a number or the address. So when you fill out a CAPTCHA, they'll give you one with the right numbers, and then they'll give you that picture. So right when you type in, when you fill out this CAPTCHA and click submit, the machine knows that this is an address of 8001 now, for sure, because you told it to. You taught it. You said, hey, that's 8001. Bet you didn't know that every time.
No.
That's how it starts.
I got musical notes.
Huh?
I once got musical notes.
Really? Yeah, it happens. And they do get more difficult now, like where they have like, it's a grid of 9 and you have to pick just the ones that has the car in it, or
Yeah,
just
yeah,
has
yeah,
the
yeah.
sign
Which
in
one
it.
is
Those are annoying.
Right, or which one is pizza. So that's just another example generation, if you will, of a more advanced CAPTCHA. There's another way that you can get all of this stuff into the machines. More specifically, Amazon really wants you to use their cloud. They really want you to use their cloud. Like, really want you to use their cloud. So instead of, with limited internet connections and stuff like that, you can't exactly upload if you have hundreds of terabytes of data to the cloud. So Amazon will send you a nice, cute, protected box that holds 100 terabytes with onboard compute, everything you need. This is a real product. This is a real product.
What
There's a
does
fire.
it
You fold this down, there's a fiber optic connection, throw in all your data,
It's a large thumb drive.
goes back to Amazon, they connect it via fiber, put all your data in an S3 bucket.
Pay for shipping.
That's one way. But what if that's not enough? What if you have a lot of data that's more than 100 terabytes, like if you're a school or a bank or something? How are you going to get all, you're going to probably need 2 or 3 or 10 of these. If you're Google, not that they would put their stuff in Amazon Cloud, but they've got petabytes of information. If you're a Department of Defense, you've got petabytes of information. So now what do? Amazon has you covered. They will send a truck to you. That little box has been expanded to the size of an 18-wheeler truck, and they will send it to you. And you can put your data in there. And this truck holds 100 petabytes of information. It's a 40-foot long, rugged container packed on the back of a truck. You connect it, you send it, and they put it in.
Free 2-day shipping.
Who knows? You're a Prime member, I don't see why not. Keep it consistent, right? So that's how you feed the machines, via captures or physically sending the data.
Can I ask a question?
Sure.
I'm really confused about the connection between the data and feeding the machine. Do they actually then use that data to feed their own machines? They're not storing it anonymously,
They're not storing it anonymously. They essentially upload it to your Amazon account,
Right.
to your AWS account, and then
Right.
you can do with it what you want from
but
there.
how does that feed the machines?
Well, then you have a dashboard, and you can say I want this data, and you put your own functions on top of the data and stuff like that. So it's manual in the sense that the data gets there, but then you still have to tell it what to do or what you want out of that data once it's there, because now it's just no longer on your local machine or not.
But you're saying
How's it teaching?
you still own
Well, I'm
use
just
that.
because the Google Capture example is an example of how Google gets data that they can then use to feed their machines.
Right.
And so I'm just not clear about how this helps Amazon, if at all. in
I don't know
feeding.
that
It doesn't help
Yes.
Amazon directly, but as you're a customer, now you can use the Amazon network, if you will. Now you put your data in their machines.
So their
You can't.
machines will allow you the access to the AI and the networks that can do the processing, but you're feeding those processes and those
So when you
queries
use
with your
Amazon
data.
Cloud, you can use their AI machines?
Mhm.
Oh, I didn't know that. Okay. That was my question.
So the most used thing right now is image recognition. No, that's not a misspelling. That's how Amazon spells it.
Wow, we should go to school.
That's annoying.
I know, isn't it?
Yeah.
Images are everywhere. Images are everywhere. Images are everywhere, and used for all random anything and everything. Here's a little bit of stats of just how many images are exactly being used. It's a lot. So imagine having to process all these images. So when you have all these images, there's different ways that you can recognize different things out of the image. You can detect the objects in the scene. You can detect anything on the face. You can compare two faces to see if this is the one person or not. You can recognize the face. If you have a whole bunch of faces, you can pick out one face depending on the different direction that it's facing. And now you can actually recognize celebrities. And this image moderation is so if there's a questionable image, it will blur it out before it shows it to you. And if you're looking at an image with a face, these are the particular data sets that you can pull from an image, from a face. These are all the things that it can tell, including the image quality, the brightness, the sharpness, if you're smiling, if there's a beard, if you're happy. So it's pretty good at detecting the sentiment of the face. Also, it can find a similar face in large images. I mean, similar face in a collection of images, rather. There's another thing that Amazon has if you're a Prime Video subscriber. They have this thing called X-Ray, where no matter what you're looking at, if you look at a scene, if you're watching a video on Amazon Video and you click the X-Ray button, it will show you what you're watching, even if the characters' backs are to the camera. It's smart enough to know what you're watching. I've actually seen it. It's actually pretty cool.
Wait, can you explain that? Because doesn't it know like what you're watching because you selected it?
Right.
In a queue?
But it doesn't know what scene you're on when you're watching the movie. You could be in a scene where it's just all space.
In this scene, it's these people.
Right, right, right. So it doesn't stay there all the time. Like there may be another scene where none of these characters are on the screen. So none of that will show up. So this, I'm going to show you another example, which is actually really cool. These things really do happen. Police use image recognition to find criminals. If you can imagine, or if you can remember all those movies that you watch where it's the criminal, he just did a crime and he's running and he's trying to cover his face so that the cameras don't see him because the cameras can recognize his image in real time. That really happened. That really happened. And a case was solved due to image recognition. The police had a case they were trying to figure out. There was no software. There was no software for them to do it. It takes days for people to look. But within 1 week of going live, they fed all the same images through a machine. They got the guy. So that's another example of how image recognition can actually be used. Coming close to the end, so don't worry.
No, it's cool.
So, any questions so far?
Can we use it for neo-Nazi rallies?
Yes. Yes, back up.
I'm having a question where most of the examples that you're showing are humans providing input for the analysis to a neural network. Are there examples that are in practice today where machines are providing that input?
Yes.
What would that
Let me think of a good one for you.
I read about one.
Good example, unless someone has one.
Yeah, there was like an AI that was trying to generate fake video content.
Yeah.
Like just completely generate novel content. And then there was another AI that was judging whether it was a real video or not. So they were both kind of training each other. And like
Yeah.
the generative video is trippy.
Yeah, what's that?
It's not a concept.
And I actually did hear that newspaper, I think it was Associated Press, is using AI to generate their news content.
3,000 articles a week are generated through AI now for
Yep.
the Associated Press. Just
Wow.
looking at both, not only the trends and understanding what's going on, but also learning what makes people most likely to click them and what makes people most likely to read them. So they're adjusting the way that they tell the story based off of that too.
Washington Post does this.
Can they make sense of Trump news?
Of what?
Trump news. There is a short film that was written by an AI.
So all in all, see, look, I'm already done. Isn't that fun? The fun actually starts now. So now, let's recap really quick. AI is basically just an intelligent machine that works and reacts like humans. Machine learning is the ability for computers to learn without being programmed. Deep learning is that machine learning with a data model. Image recognition is everywhere. It can recognize you no matter what, even if your face is turned to the camera. And a neural cell transfer is essentially using machine learning to redraw an image based on a source image. Right? So, with all these examples, with all these things, there's always the best part of every presentation called playtime, where you get to actually see these things working. So I have some of my little machines. This here is a drone. It's a hover camera. And it's a artificially intelligent machine. Why? Because it hasn't been programmed to do certain things, but it just doesn't. Here's an example. Yes, this is me. This past weekend, and I was playing with my camera, and this here, this camera, is programmed to follow me on my bike. The camera is following me right now on my bike as I'm driving, as I'm riding. I did not program it to do that. I just said, this is me, and follow me. This is riding my bike around my house. There's going to be something very cool that happens in this video towards the end. While this is floating, I can do things like this. And it can balance itself. Even if I try to mess it up.
Oh my
Right here, it lost me. It lost focus of me in the camera. This is how intelligent this is. If you keep watching, it's looking for me. I'm trying to stay in range, and then it finds me. All by itself. I had my phone in my back pocket the entire time.
So cute.
AI at the edge. Remember I showed you there's going to be AI at the edge, the drones? That's what these are. And so it basically recorded a 4K video when I did that, and that's what you just saw. That is essentially the forward part of my presentation, so thank you. Any other questions?
Where'd you get those pants?
Nice car, by the way.
Thanks. This was the weekend. It was yard day, so I was busy in the backyard, things like that. Yes.
What is a neural network?
A neural network is a network essentially made up of machines that use a data model to determine whatever you need it to, essentially. I do actually have one more thing, but it's going to require you to get up. You don't have to get up now. One at a time, and I'm going to show you what you're going to be doing.
Dude, I already got attacked by a drone.
You just about got a free haircut.
I have one more question.
Yes.
So the definition of machine learning that you had up is that it can do things without being programmed, right?
Right.
But in that case, is the camera at least programmed to follow, or you know what I mean? Like not follow you, but there's
Well, it's
certain
programmed to follow a target.
Yeah.
So what I did before I let it go, before I got on my bike, I told it that I'm the target. It comes up with a box, and I said I'm the target,
Okay.
and then it just
So
says
there's
it just follows me.
program functionality,
Right.
but it's
So it was a facial recognition? Or
Me as the object.
Okay, so.
So it wasn't facial recognition. It was just
We
me
would
as the
never
object on the
objectify
screen.
you.
You're a whole person, guys.
Feel like you feel mine.
This is
Objects like women, man.
I forgot.
what he said.
So I have some demos here, real time, of facial recognition. As you can see, it's in real time,
That's fantastic.
trying to determine my
It knows your face.
emotions. I have another example here where it will determine if I'm male or female.
Is it gonna pass the aggressive?
The beard might be away.
Darn it. There it goes.
You need a filter for that.
Croatian filter.
So kind of off and on. This is rough. This is running on my local machine, and it kind of works. But what's even funner things like this, where I can actually put someone else's face on top of my face.
Flawless.
I could be Sean Connery. I could be Obama.
I want to see it. Get one.
Nick Cage.
Bieber.
It takes a while.
It's like if you had a baby with these people.
Nick Cage, right there.
Yeah. Face off.
Wait, what is happening?
It's figuring it out.
It's because you're moving.
There's a Nick Cage growing out of your head.
You know, you're kind of backlit. Maybe you should.
There's another one that's kind of funny.
Just a quick action.
Like this small.
Make it.
In a house.
So these are running actually right here on my machine. The reason why I say get up is because obviously they're running.
Turn it off. If I do. Queen, you can't escape her.
So it's here to play with. If you want to come see what you look like as Obama or any one of the other celebrities there, this is purely for fun. I did it. I just whipped something together really quick just for everyone to play with. So that's essentially the end of my presentation. If you'd like to come play, come on. It's free for everyone.